This question looks hard, but we can use some strategies to help us. There is definitely algebra we can do, but my guess is if you're watching this video that algebra doesn't feel good, or you're just nervous about it, or you did it and you still got it wrong. So let me give you an alternative. What I see here is absolutely I have equations, right? I have one in the top part of the question, then in all the answer choices. And this question also uses a phrase that I think is really good to notice, in terms of. It's basically telling us rearrange the top equation so it looks like the bottom. And it's also code letting us know that we can use a strategy known as arithmetize. They're giving us equations, but they're never telling us to solve for k or solve for m or j, right? There's no number attached to any of those letters. We're never asked to find any number, so the number doesn't matter. What arithmetize lets us do is just make up some numbers. In a way, this is the plug points into equations strategy. I have equations. I'm looking for points. I'm not seeing any. Can I make up some points to plug in? And it's a little weird because there's 3 variables, but it really doesn't bother me because with practice, you'll know that this is going to work when these variables are never solvable. So we can just make up some numbers. What I'm going to do is I'm going to make up numbers that are really easy. So I'm going to make it so that j is equal to 1 and k is equal to 1. Really simple numbers. And when I do that, it's going to let me solve for m. So I'm making up the 2 1s randomly. I am not making up a random number for m because the m is kind of coming from the j and the k. So if I choose different numbers for j and k, I'm going to get a different number for m. So I'm going to let the equation kind of do its work and solve a number for m for me. So in this case, it's really simple. J is 1, so I plug that in. K is 1, so I plug that in. 14 times 1 is 14. 5 times 1 is 5. So 14 plus 5 is 19. So that is my value of m. So here you might want to just kind of highlight, if this is your scratch paper, just kind of put it somewhere that it's organized. You really don't want to lose track of the numbers you picked because now we're going to use them again. We need to test these answer choices. With these numbers, these points, it worked in the first equation, right? We got all these numbers to kind of fit together in a nice way. They also need to fit together in the answer choice in order for the answer choice to be correct. So here's how this is going to work. I'm going to actually do choice D first because it's a little simpler. So just to kind of keep everything on the page, K was 1, M was 19, and J was 1. So now we have to simplify this. What is 5 times 19? You got your calculator. 5 times 19 is 95, and 14 times 1 is 14. So that's supposed to equal 1. Is it? No. 95 minus 14 is 81. So no. In order to pick D, we would need the right side of the equation to match with the left side. We would need 1 equals 1, and that did not happen here, so we know that choice D is wrong. We can do the exact same thing in all the other choices. So K, like we said, is 1, and 14 times 1, right? J is 1. We got to keep track of everything. M is 19, so let's plug that in. And then 5 is on the bottom. So it's a little messy, but 14 times 1 is 14. Minus 19 is negative 5. So negative 5 over 5, it's close, but it's not the same. Negative 1 and 1 are different numbers. So the fact that it's close does not count. It needs to be the exact same thing. So this is also provably wrong. Moving on to choice B. Here we'd have 1, right? That's our value for K. 1/5 of 19, that's our M, minus 14 times 1. Now, if you pick up your calculator and you do 1/5 of 19, which is the same as 19 divided by 5, you're going to get a messy number. You're going to get 3.8. And you could probably stop here because our answer choice, or the correct value that we want, is 1. So we just introduced this weird decimal, and we can see that that's not going to go away, right? We're subtracting 14 from that, so we're not going to kill the decimal. It's just going to linger. And this is a useful strategy or a useful way of thinking about some of these arithmetized questions, is sometimes we don't need to finish the job. We can kind of see where it's going wrong, right? Maybe we get a negative number, but we know we need a positive, right? Maybe we get a decimal when we know we need an integer. So we're probably going to end up picking A here, but let's just prove it. In this case, we still have K is 1, M is 19, J is 1, and that's over 5. So what happens? Well, 19 minus 14 is 5, and 5 divided by 5 is 1. So there we go. That worked. Now, obviously, if I had started in the right order and done A first, that would have worked, and I would have kind of shown that that was the correct answer right away. But we do need to check every choice. So even if I had gone in the right order here and A worked, I wasn't done. I would have had to go through B and C and D and double check, because occasionally we happen to pick numbers for our variables that work in multiple answer choices. It's not the end of the world. There are ways of dealing with it by just picking new numbers, but even still, sometimes it's enough to eliminate some garbage answers so that you can kind of figure out which of the two that remain is the right one. This strategy takes practice. It's unusual. It's not something you're doing in school, but it's really helpful when the algebra gets confusing. So for many of you, if you looked at this question and you just were like, uh-oh, 3 letters? Look at these answer choices. These look crazy. I don't know about this. Good. Trust that feeling. That's your brain telling you, I don't want to do algebra. Arithmetize is our way of listening to our brain and avoiding it by doing arithmetic instead.